Hi, I'm Jessica, an engineer at Liquid Instruments, and today I just want to answer one question. What is Allan deviation? Originally formulated to assess the stability of oscillators in atomic clocks, Allan deviation and Allan variance provide a very robust measure of frequency stability over varying timescales. Statistics like standard deviation aren't able to take these varying timescales into account, and there are a lot of sources of instability to consider that become more or less impactful depending on our timescale. The basic principle of Allan variance is to divide a time series into sections of equal duration. And then we want to consider how the time average of each section compares to that from a previous section. If these differences are small, then the system is overall stable on this timescale. And then Allan deviation is the square root of Allan variance, much like standard deviation is the square root of standard variance. Let's walk through what an Allan variance result actually means. So if we have an Allan variance of about 1.23 times 10 to the negative 10th for a 10-second observation, where that 10 seconds is our tau averaging time, then we expect two randomly chosen consecutive 10-second intervals to differ by about 1.23 times 10 to the negative 10th RMS. For me, it's just more helpful to see this on a plot, preferably in real time as I'm taking my measurement. So I'm going to measure this using the Moku Phasemeter, where I can measure Allan deviation in real time with very high precision. As tau, our averaging time, increases, we can begin to see more and more data populate. We also can assess how different sources of noise dominate our response at different averaging times. For instance, at low frequencies, we expect to see contributions from white noise in our results. As that white noise begins to average out over longer intervals, our dominant source of instability will be flicker noise. After this plateau for longer averaging times, we'll start to see mainly drift limit our stability. And then we have this kind of lopsided U shape, which is a typical Allan deviation plot of an oscillator. For now, I'm just measuring an inexpensive voltage-controlled oscillator, but some oscillators are far more stable, like atomic clocks or sapphire oscillators, for really good short and long-term stability. If you have any questions, feel free to drop them in the comments below. And if you want to learn more, you can read our Allan variance app note, which will be linked in the description box. Thanks for watching.